Hello, I hope you're having a wonderful time. We are going to transform the ketone into an amine, and the process we want to employ is the Gabriel amine synthesis. Now, looking at the starting material and the product, and thinking about what we have in the lecture notes, you will realize that this is not the typical Gabriel amine synthesis. The Gabriel amine synthesis starts from phthalimide in the presence of an alkyl halide. Now in this case we are starting from a ketone, which means we need to transform the ketone into an alkyl halide, and we need to think of how are we going to do the retrosynthesis. What are we going to disconnect so that we can put it back together? So the best way is we can look at this as carbon number 1, 2. So this is carbon number 1, 2, which means we can cleave it between carbon number 1 and the nitrogen. We can cleave it there and install the amine. So what we already have is this portion here. We can generate it from the phthalimide. And then we need an alkyl halide. The alkyl halide, we can transform this ketone into an alkyl halide. So first of all, let us find out how we can transform it into an alkyl halide. So that means we are going to do something like, we want it to be in this format. And to do that, that means we are installing bromine in the alpha position. Now that requires the use of catalytic amount of an acid together with Br2. Once we form this compound, then now we can start our synthesis. So we can start from the phthalimide, and then we can use potassium hydroxide as a source of our base, which is OH minus 1, 2, 3, 4, 5, 6. So this will be able to deprotonate, that we end up with an amide. So we're going to have 1, 2, nitrogen, then now we can add, so that one plus 1, 2, 3, 1, 2, 3, and we have connected to ER. So once we have the amide is going to attack, the alpha carbon, and it kicks out the bromine in an SN2 format. So we form 1, 2, 3, 4, 5, 6. Nitrogen, and now this is connected to this one carbon in between, and after that we can do hydrolysis to transform the amide, to transform this the amide portion into carboxylic acid and amine. So that gives us NH3 plus, and of course plus OH, and for this specific one we can now use a base. So we can use something like sodium hydroxide to transform it into the product that we were interested in. NH2. We missed one carbon over here. NH3 plus. So now we end up with the product that we were interested in, and we have been able to employ the Gabriel amine synthesis and transform our ketone into an amine.